In this question, we have an isotropic material which is subjected to a compressive stress sigma z, and it is confined so that it won't deform in the directions x and y. In part A, we would like to find if there are any stresses in x and y directions. If there are, we will find the equations for them. In part B, we will determine the stiffness in the direction of sigma z. And finally, in part C, we will discuss what happens if Poisson's ratio approaches 0.5. Let's start making some observations, then we will continue with the solution. Because of the rigid die, the material won't be able to deform in x and y directions. So, epsilon x will be 0. Similarly, epsilon y will be also 0. Now we can continue with the part A. Do stresses occur in the x and y directions? Yes, there are stresses in x and y directions because of the rigid die. Let's write their equations then. We know that epsilon x is equal to 1 over e times sigma x minus Poisson's ratio times sigma y plus sigma z. And similarly, epsilon y is and they are both equal to 0. This gives us sigma x is equal to Poisson's ratio times sigma y plus sigma z, and sigma y is equal to Poisson's ratio times sigma x plus sigma z. We will make some arrangements so that we can find the equations for sigma x and sigma y. Let's add them first. And we get and now I will subtract sigma y from sigma x. This equation gives 1 plus Poisson's ratio times sigma x is equal to 1 plus Poisson's ratio times sigma y. And sigma x is equal to sigma y. Let's substitute this into the first equation so that we get 2 sigma x is equal to 2 times Poisson's ratio times sigma x plus 2 times Poisson's ratio times sigma z. And finally, we get sigma x is equal to Poisson's ratio over 1 minus Poisson's ratio times sigma z, and it is equal to sigma y. Let's move on to part B. We know that similar to epsilon x and y, epsilon z is equal to 1 over e times sigma z minus Poisson's ratio sigma x plus sigma y. We know sigma x and sigma y are equal, and we know them in terms of sigma z. So let's substitute the values. And it is finally now. Let's move on to the stiffness. We know that stiffness in the z direction is sigma z over epsilon z. We know sigma z and epsilon z. So I will write their equations. When we make some arrangements, we get E times 1 minus Poisson's ratio over 1 minus Poisson's ratio minus 2 times Poisson's ratio square. And it is written as this. For Poisson's ratio is equal to 0, we know that E prime is equal to E. Let's move on to part C. What happens if Poisson's ratio approaches 0.5? We can see that in the equation for E prime, we have 1 minus 2 times Poisson's ratio. And when Poisson's ratio approaches 0.5, this term here approaches 0, which makes E prime approach infinity. So we can say that as Poisson's ratio approaches 0.5, stiffness in the z direction becomes very huge. And that's all.